Need to estimate our passage time. This lesson teaches RYA Coastal Skipper and Yachtmaster Theory students everything they need to know about tidal streams. Whenever we're navigating in tidal waters, we need to take account of tidal streams. We need to construct efficient passage plans which make best use of favourable streams and avoid areas which might become uncomfortable or even dangerous in certain conditions. We need to estimate our passage time and continually update our ETA, allowing for the tidal streams we are likely to suffer. When calculating a course to steer, we must allow for the predicted strength and direction of the tide. And when working out an estimated position, based on our origin, course and distance sailed according to our log, we must factor in the tidal streams we have suffered. Take a look at the southeast corner of your RYA Chart 3 and imagine that you are planning a passage from Port Slade on Slade Island to Port Fitzroy via Fiddler's Race, a distance of approximately 20 miles. See the sailing direction on page 69 of your training almanac. Note the final paragraph, which tells you that slack water exists for approximately 30 minutes at the change of the tide, and that this occurs at high water Victoria plus 2.5 hours and at high water Victoria minus 3.5 hours. If you inspect the tidal atlas in your almanac running from page 13 through to page 25 and concentrate on what's happening to the northwest of Fiddler's Race between high water Victoria minus 4 hours on page 15 and high water minus 3 hours on page 16, you will see that between the two the tide turns from setting northwest to southeast, and you can assume that, as stated in the sailing directions, the period of slack water will occur halfway between minus 4 hours and minus 3 hours. And if you take a look at what's shown on pages 21 and 22, which depict the situation at 2 and 3 hours after high water, you can see that the tide turns again, this time from southeast to northwest. Incidentally, when we're describing tidal streams and we say that the tide is setting in such and such a direction, it means that the tidal stream is taking you in that direction, and we call the speed at which it's taking you there drift, or the drift. Sometimes the word drift is omitted. For example, if we were to say the tide is setting southeast at 1.7 knots, we would mean that it is setting southeast and the drift is 1.7 knots. Alternatively, we could say that the tide is setting 135 degrees at 1.7 knots. And some people use direction and speed, which mean exactly the same as set and drift in this context. Note that, in common with everything else that's written in an almanac or appears on a chart, the set is always given relative to true north. The figures alongside the arrows give the drift on an average neap tide, the first figure, and on an average spring tide, the second figure, omitting the decimal point. So in this example, 1.4 knots on an average neap tide and 2.6 knots on an average spring tide. Incidentally, the dot in between the neap and spring drift figures is that actual location where the measurements were taken. So, going back to our hypothetical passage, we know that we want to navigate Fiddler's Race, a distance of approximately 4 miles, either around about 3.5 hours before high water Victoria or 2.5 hours after. So we try to time it so we arrive at the northwest end about half an hour before slack water, so at either high water minus 4 or high water plus 2. Of course, it also makes sense to take advantage of the strong tides in Neptune Channel to reduce our passage time and save diesel. So if we want to carry the tide down from Port Slade, it makes sense to plump for arriving off Beauty Point 2 hours after high water Victoria. Incidentally, you've probably noticed that despite the fact that we're navigating in the far southeastern area of our chart, we've been referencing the tidal atlas according to the time of high water in Victoria, right up in the far northwest, nearly 40 miles from Slade Island. This is made clear by what's written at the top of every page of the tidal atlas. At first, this can seem a little confusing, but if you think about it, the only way a tidal atlas can be constructed is to use a single reference port. Actually, it could be any standard port because, as you learned earlier in the course, they're the ones that have tide tables in the almanac, and, in terms of tidal streams, the time difference between the turn of the tide in, for example, Victoria and Port Fraser is a constant. The key thing is to remember to always use the tables associated with the reference port wherever you are working on the chart. So in the RYA training world, the mantra is Victoria, Victoria, always Victoria. So going back to our passage, let's imagine that it's Tuesday the 26th of March. We refer to the tide tables for Victoria on page 33 and see that there's a high water at 0822 UT. But hang on a minute, we're in the Southern Peninsula. So, assuming we've set our watch to the town hall clock in Port Slade, that's 0922 local time. You'll recall that when we set out this example, we assumed that we were going to be making the passage on an average spring tide, meaning that we could take the larger of the two figures alongside the arrow in the tidal atlas for drift. But of course, this will rarely be the case, as most tides' range will actually be larger or smaller than an average spring tide. Look at the prediction in Neptune Channel at high water Victoria +5. You can see that the tide is setting pretty much west, and that, on an average neap tide, the drift will be 2.5 knots. And on an average spring tide, it'll be 4.9 knots. Quite a big difference. If we take a look in the top right-hand corner of the Victoria tidal curve on page 36, we can see that the mean spring range at Victoria is 4.9 meters, and 2.4 meters at neaps. The 26th of March is somewhere between springs and neaps, so we need a way of working out the actual drift. To do this, we first have to work out the mean range at Victoria on the 26th of March. We do this by calculating the difference between the heights of tide at 0207, 1.4 meters, and at 0822, 5.2 meters, giving a range of 3.8 meters. Then again between 0822 and 1438, 4.3 meters, and between 1438 and 2055, 4.4 meters. Now we average the three ranges, so 3.8 plus 4.3 plus 4.4 equals 12.5, which, divided by 3, gives an average range of 4.16 meters. Let's call it 4.2. Now we use a special tool for computation of rates, which you can find on page 26 of your almanac, or you can download a copy from the Resources tab. Enter the neap drift, 2.5 knots, onto the blue neaps horizontal line on the tool, and the spring drift, 4.9 knots, onto the red springs horizontal line. Now draw a line from top to bottom of the tool through the points you just plotted. Then a line horizontally across from the left-hand axis at 4.2 meters, which was the average range on the 26th of March, to intersect the diagonal line, and from the point of intersection, up or down, doesn't matter which, to the scale running along the horizontal axis, which tells us that the drift at high water plus 5 hours will be 4.3 knots. Charts incorporate little purple, or more correctly magenta, tidal diamonds, giving the same information. The one for RYA chart 3 is right at the top of the chart. Here you can see that there is an exact correspondence between the tidal atlas and the table at tidal diamond N, just north of Beauty Point. At high water +5, both atlas and table tell us that the tide should be setting 303 degrees at 2.6 knots on an average neap tide, and at 5.2 knots on an average spring tide. Notice that the tidal atlases present the drift as neap springs, and tables give springs neaps. There's no rhyme or reason for this, and it shouldn't really confuse you, because of course the larger number will always be the spring drift. Sometimes you will have a tidal atlas for the area that you are navigating, but not always, as they're not available everywhere. So you'll have to work from a chart. Other times you'll have a tidal atlas at a much larger scale than the chart you're working off, with much greater detail, so you would use the atlas in favour of the tidal diamonds. In general, tidal atlases give you a better overview of tidal stream for passage planning, but tidal diamonds really come into their own when you're calculating a course to steer or estimated position over a number of hours, because they save you from having to flip back and forth in the atlas. Remember, when you're getting your information from a tidal atlas or tidal diamonds, the set and especially the drift are only a guide, and, just like tidal heights, can be greatly affected by meteorological conditions, especially strong winds blowing continuously for days from the same direction, which can set up surface currents on top of the underlying tidal streams. Of course, stream predictions are often widely spaced on the chart. Take a look at these two, northwest and south of Farlow. On a spring tide, set and drift northwest Farlow is predicted at approximately 193 degrees, 2 knots, and south of Farlow it is predicted at approximately 286 degrees, 3.1 knots. If we were midway between the two, it might be tempting to average set and drift, getting 240 degrees and 2.55 knots. Unfortunately, you cannot average vectors like this. If you were to drift 1 hour 240 degrees at 2.55 knots, you'd end up at point A. Whereas, if you were to drift 193 degrees at 2 knots for 30 minutes and 286 degrees at 3.1 knots for 30 minutes, you'd end up at point B. And if you're planning to cruise the Mediterranean, you need to know that whilst there isn't much of a tidal range, there are significant currents that can help or hinder you and need to be taken account of. For example, a cruise around the Adriatic should follow an anti-clockwise route. Similarly, at a global level, driven by the prevailing winds and the Coriolis effect, there are major ocean currents, such as the Gulf Stream and the Agulhas current off the Eastern Cape, that can run at up to 4 knots, which is not only a significant factor in passage planning, but can create very nasty or dangerous conditions for even the largest of ships. Okay, let's focus down on determining the set and drift at a specific time and location. I suggest that you follow along on paper, taking your time so that you're confident of every step. Imagine we need to calculate the set and drift in the area southwest of Cape Woodward, in the vicinity of tidal diamond F, between 11:30 and 12:30 on Tuesday the 23rd of April. From the tide tables for Victoria, remember Victoria, Victoria, always Victoria, we can see that there's a high water at 0658, let's call it 0700, UT. Add 1 hour to give it in daylight saving time. Now, the best thing to do is to construct a simple ladder diagram, like this. Start from high water at 0800, which means that the high water hour runs from 0730 until 0830, and the high water plus 1 hour runs from 0830 until 0930, and so on, until we get to high water plus 4, which is the hour we are interested in, 1130 until 1230. By inspecting the table, we can see that at tidal diamond F, at 4 hours after high water Victoria, the tidal stream will be setting 276 degrees, and that on an average spring tide, the drift will be 3.6 knots and 1.8 knots at neaps. On the 23rd of April, the height of tide goes from 1.8 up to 4.8, giving a range of 3 meters, then down to 1.2 meters, a range of 3.6, and back up to 5, a range of 3.8. If we then average these three ranges, we get 3.46 meters. So, on the computation of rate tool, we enter the drift on an average neap tide, 1.8 knots, and the drift on an average spring tide, 3.6 knots, and join the two, extrapolating out to the top and bottom scales. Then enter from the left at our average of 3.46 until we meet the diagonal line, then up or down to find the actual drift, which is 2.6 knots. So, on the 23rd of April, between 11:30 and 12:30, daylight saving time, the tidal stream at F will be 276 degrees true at 2.6 knots. Obviously, you can apply exactly the same procedure to set and drift extracted from a tidal atlas. If you're navigating in a river, estuary or channel, the tidal stream associated with the rising tide is said to be the flood, incoming, or colloquially, making tide. And the stream associated with the falling tide is said to be the ebb, or outgoing tide, or colloquially simply away, as in the tide's away. The term on the turn of the tide, or simply on the turn, is, rather obviously, used to describe a tidal stream that is changing from flooding to ebbing, or vice versa. In rivers and channels, the tidal stream will be strongest in mid-channel, and its weakest close to shore. And when the tidal stream turns in a channel, it will first reduce and turn on the edges, in the shallowest water, before it weakens and turns in mid-channel. Sometimes this can be very marked, so if you're planning a passage up or down a channel close to the turn of the tide, navigate offshore if the tide is going to turn against you, and inshore if it's going to turn in your favour. Headlands and constrictions cause streams to accelerate markedly, and it's here that you are most likely to encounter tidal races, which can cause overfalls, which are nasty, steep and potentially breaking waves at certain states of a tide, especially if wind and tide are in opposition. These will be marked on large-scale charts, often with accompanying warnings, and will be mentioned in sailing directions in the almanac. Incidentally, the turn of the tide does not necessarily correspond with the times of local high and low water. For example, off Portland Bill, where there is a notorious tidal race, the tide turns from a west-going ebb to an east-going flood between 4 and 1 hours before local high water, with slack water and minimal overfalls at high water -3. Click the Start button to view an animation. OK, well done. You've completed the lesson on tidal streams. Now go on to attempt exercise D.